Alright, in this video we're going to talk about another way that we might try factoring if factoring is something that doesn't go so well for us. So we're going to start with this age-old problem, expand the binomials. For most of us, what we're going to do is we will go through the FOIL process and do 3x times 2x, 3x times negative 1, two times 2x, and finally 2 times negative 1, and combine like terms. And we have this. Now I'm going to propose a different way of doing this. We know that to find the area of a rectangle we do base times height. And what we could sort of think about here is this is base, this is height, this is equal to some area. So I'm going to draw myself a rectangle, and across the top I'm going to label it 3x plus 2. I'll actually divide it this way. So the width of this box is 3x, and the width of this one is 2. Down the other side, the dimension is going to be 2x minus 1. And I'll again divide it up this way. And what we can do is we can find the area of each of these small boxes. So the area in this top left box is going to be 6x squared. The area in the top right, we would do 2x, which is this side here, times 2. Across the top, we have 4x. The bottom left, the area of this box would be negative 3x, and the bottom right would be negative 2. And these are the areas in these boxes are these 4 terms that we have when we go through the FOIL process. So, okay. This is really nothing new. I would take these 2 boxes here and combine them to get our positive 1x. But I want you to notice something. I want you to notice this box and this box. What do they multiply to? They multiply to negative 12x squared. And if we look the other here and here, those also multiply to negative 12x squared. So keep this observation in mind. We're going to use this area model to help us factor. And it's really great for people if they struggle with factoring from time to time. Alright, so here we go. Here's a quadratic, 2x squared plus x minus 3. And the time that quadratics really get hairy for people is when we start throwing coefficients in front of the x squared. That's when it gets really hard, people say. So I'm going to factor this using a box. I'm actually going to put a circle in the middle of this box just to help me organize. And what I'm going to do is I'm going to write my quadratic. 2x squared plus 1x and minus 3. Now remember, the diagonal boxes, so the top left and bottom right, and similarly the top right and bottom left, always had to multiply to the same thing. So we need to multiply to negative 6x squared. And these 2 empty boxes had to add up to give us this plus 1x. So I need things that multiply to negative 6x squared and add to give me 1x. And if you're not sure, you start making a list of factors for 6. So we could have 1 and 6, or 2 and 3. And we need it to be negative when we multiply, so there has to be 1 positive and 1 negative. So we could go 3x and negative 2x, like that. Do those add up to the positive 1x that I want? Yeah, they absolutely do. And they multiply together to give me this negative 6x squared that I needed. Okay, so how does that help factor? That's the big question. That's the whole goal with this. If you know how to deal with greatest common factor, we're good to go. We're going to look at each column and each row and factor out the greatest common factor. So in the first column, what's the greatest common factor to 2x squared and 3x? It's x. In the second column, what's the greatest common factor to negative 2x and negative 3? It's negative 1. The first row, what's the greatest common factor there? 2x. And the greatest common factor in the last row, in the bottom row, it's 3, positive 3. So these things on the outside, if we look back at how we use this box method to expand, those things on the outside, those are our factors. So we have just finished factoring this quadratic, and it's x minus 1 times 2x plus 3. If you've looked at other methods, this is exactly the same thing as splitting the x term, it's called sometimes, but it provides us with a visual organization tool to help us not get so confused. So there we have it, short and sweet. That's how we can use a box and thinking about area to help us with something that gets complex, such as factoring.